Hello, dear students. Welcome back to your physics class. I hope you are all doing well. In today's lesson, we are going to explain Chapter 2, Physics for Grade 10. In a previous lesson, we finished Chapter 1, all sections. In this video, I will explain Chapter 2 about the strength of solids. So in this chapter, just for information, we have two sections. Section 1 about the phase of matter and the forces among their molecules, and section 2, the solids and their properties. Let's get started from section 1, chapter 2, section 1. Okay, so in this section we will dive into the composition and the phase of matter. So as you know, we have four phases of matter: solid, liquid, gas, and plasma. So we will explain one by one in detail. Be with me and listen carefully, please. Okay, guys, look, in this section 1, we will talk about phase of matter and the forces among their molecules. The phase of matter, we have three phases of matter, are usually easily recognized as a solid, liquid, and gas. Okay, and so the definition of phase, what is phase? One of the four stages of matter: solid, liquid, gas, or plasma. Okay, so we have four stages of matter: solid, liquid, gas, and plasma. So what is plasma? Plasma, a phase of matter achieved at very high temperatures. What is plasma? A fourth state of matter achieved at very high temperatures. So at a very high temperature, the state of matter becomes what? Becomes a plasma. Okay, so the fourth state of matter is plasma. At high temperature, a fourth phase is achieved. This phase is called plasma. It consists of what? What does the plasma state of matter consist of? It consists of atomic nuclei, and electrons, all moving with very high speed. Okay, so the electrons in the plasma phase are moving with a very high speed. Stars are at high temperatures, and most of the mass of the universe is concentrated in the stars. So it has been estimated that 90%, how many percent? 90% of all the matter in the universe is what? Is plasma. Okay, 90% of all of the matter consists of plasma. Now, we will distinguish between solid, liquid, and gas. At first, in the shape. What are the differences between solid, liquid, and gas in shapes? Look, for the solid, you know that solid has definite shape. Solid has what? Has a definite shape. But liquid take the shape of its container. It depends on the container, so has no definite shape. Liquid has no definite shape. What about gas? Gas also has no definite shape. Which of the following has a definite shape? Which phase of matter has a definite shape? Solid, liquid, or gas? Solid. Okay? But liquid and gas, they don't have a definite shape. The volume. Solid, like it is shape, like the shape, it has also the definite shape. Okay, can we say solid has both definite shape and definite volume? Yes. Solid has definite volume and definite shape. But liquid, also about the volume, liquid has definite volume. Liquid has definite volume but no definite shape. But gas, no definite volume, no definite shape. The gas, neither definite shape nor definite volume. Which of the following has neither definite shape nor volume? Gas. Which of the following phase has both definite shape and definite volume? Solid. Which of the following phase of matter has definite volume but not definite shape? Liquid. Okay? So about the arrangement of particles. So what is the difference between the arrangement of particles between liquid, solid, and gas? The arrangement of particles for the solid, tightly packed in irregular pattern, as you can see in this figure. So this is the shape of what? Of the solid state. Tightly packed in a regular pattern. So all the molecules and the atoms attached to each other with a very large force of attraction. Okay, but of the liquid close together with a regular arrangement. Okay, the distance between the atoms of the liquid is more than the distance between the atoms in the solid state. So that is why in the solid state, the arrangement of particles is packed together and attached to each other with a very large force. so that is why it has a definite shape and definite volume. But for the liquid, the distance between the atoms there is a little separation between the particles of the liquid, so that is why the water has wave, and the particles or the molecules of the liquid slides to each other, or passes or slides to each other. So that is why the water or the liquid has like a wave, and the particles moving or sliding to each other. But the gas, the arrangement of the particle of gas far apart, the distance between the particles are far away from each other, so that is why it has no definite shape nor definite volume. In a particle movement, how the particle movement in a solid, liquid, and gas. So what are the difference between the liquid, solid, and gas in a particle movement? The particle movement in a solid state vibrate in place. So the particles in a solid state vibrate in its place as a simple harmonic motion. The particles in a solid state vibrate, but we cannot see with our naked eye, but under the microscope we can see this vibration of the solid state. All atoms in a solid state vibrating in its places, okay, without movement, with zero displacement. The particles in a solid state vibrate in its place with a simple harmonic motion, okay? But in a liquid, vibrate and move past each other. The particles vibrate, but it is moving to each other, past each other. In the gas, move freely at a high speed. The particles in gas move freely and at a high speed, move freely at a high speed. So both the liquid and the gas, their particles are moving, slides, passes each other, moving freely at a very high speed. But solid, the particle does not move. The particles vibrate, only vibrate, without movement, without displacement. The displacement of the particle is zero. Compressibility, the compressibility of the like solid, liquid, and gas, there are a lot of difference between the solid, liquid, and gas. Solid, incompressible. Solid is incompressible. We cannot compress solid easily. It requires more force to deform or to compress the solid state. But under a small force, we cannot compress the solid state. So that is why the solid state cannot be compressed or incompressible. But liquid, slightly compressible, not more, comparing with the solid. But gas is highly compressible. The gas state can compress very easy under a small amount of force. Intermolecular forces, the forces between the molecules in the solid, liquid, and gas. In a solid, the force between the molecules are very strong. So that is why the particles and the molecules pack it together and attach it to each other with a very large force. This force is called the force among or between the molecules. And moderate in the liquid, and the weakest force between the particles in the gas state. Why? Because the particles are far away from each other, so that is why the force between the particles in a gas state is very weak, and the weakest force exists between the particles in a solid state. But this force is the strongest, and the strongest force between the particles in a solid state because they are very close to each other. Example of solid like ice, wood, metal. Okay, so we have many examples of a solid state. For the liquid like water, juice, and oil. And for the gas like air, oxygen, and helium. So this is generally the differences between liquid, solid, and gas. Does matter really exist in three phases? Is it possible for the matter to exist in three phases? Yes, of course. Like ice, for example, can be boiling and melting into the liquid, and the liquid can be boiling into the vapor. Yes, like for example, ice, for example, can melt to form water, and the water can boil to become a water vapor. Like for example, H2O. Okay. At first, like ice cube, guys, look. An ice cube. Ice cube is what? Is a solid state. Solid. Ice cube, by giving thermal energy to the ice cube, this ice cube convert to what? To water. Okay? To what? To the water. And the water is what? A liquid. So how can you convert ice cube to the water? Both of them is H2O, okay? Without changing the matter, okay? Ice cube can be converted to the water by giving them what? By giving them thermal energy. By what? By thermal energy. The ice cube can be melted into the water. So the water can convert into what? To the vapor or water vapor. The vapor, the phase of vapor is what? Is gas. So all of them is H2O. Yes, all of them H2O. So can a matter exist in three phases? Yes, of course, like ice cube to water and the water into the gas. Can matter convert from one phase to another? How? If is it possible, how? Explain your answer. Can matter convert from one phase to another phase? Can matter convert from one phase to another phase? Yes, absolutely. By giving them what? By giving them mechanical energy or thermal energy, we can convert a phase of matter from one phase to another phase. Like, for example, by giving energy to the ice cube, energy as the heat or mechanical energy to the ice cube, this ice cube will be converted to what? To the water and to the liquid. Okay? Yes, the answer is yes. Many materials can be transformed from one phase to another by giving them what? Mechanical or thermal energy. By giving them what? Mechanical and thermal energy. So by giving them energy, the phase of matter convert from one phase to another phase. So this is done by changing their pressure and temperatures. By changing what? Pressure like mechanical energy and temperature like thermal energy. So matter is composite of the molecules and atoms. Certain terms use it when the dealing with the molecule structure of matter needed to be defined as this stage. Like we have some definitions, guys, here about the molecules. Okay, what is the mole? Mole is the amount of substance. What is mole? Is the amount of substance. We studied in the section 1 in chapter 1, if you remember, the fundamental the fundamental units of the physics. We had two different types of quantity: fundamental quantities and derived quantities. In the fundamental quantities, if you remember, we had mole, the amount of substance. What is mole? Is the amount of substance that contains as many entities as there are atoms in 0.012 kilogram carbon-12. What do you mean by this? It means that in 1 mole, guys, look, 1 mole is equal to how many kilogram of carbon-12 is equal to 0.012 carbon-12. Okay? 0.012 kilogram of carbon-12. Kilogram of what? Carbon-12. In 0.012 kilogram of carbon-12, how many moles do we have? We have 1 mole. 1 mole of a substance is equal to how many kilograms of carbon-12? 0.012 kilogram of carbon-12. So what about if we say 1 mole? Can we say 1 mole is equal to 12 gram of carbon-12? Yes, of course. Why not? Because just we converted from kilogram to gram. 0.012 kilogram is equal to how many gram? We have to multiply by 10 power 3. If you multiply this number by 10 power 3, you will get 12. Okay? 1 mole, we have 12 gram of carbon-12. This is mole. The atomic mass unit, U. 1 atomic mass unit, 1 U. What do you mean by U? The atomic mass unit. 1 atomic mass, it is equal to 1/12 of the mass of a single atom. 1 atomic mass unit is equal to what? 1/12. Look, guys, 1/12 of what? Of a single atom. 1/12 of single atom of what? Of carbon-12. 1/12 single atom of carbon-12 is equal to atomic mass unit, which is equal to what? 1 atomic mass unit is equal to 1/12 carbon-12, which is equal to what? 1.66 times 10 power negative 27 kilogram. 1 power 10 to the power what? 27 kilogram. This is 1 atomic mass unit. The molar mass, what is molar mass? Is the mass per mole. What is molar mass? Mass per mole. Okay? Like for example, molar mass is equal to the mass of substance divided by what? By mole. Okay? And measure it in what? Kilogram mole inverse. What is molar mass? Mass per mole. The mass in 1 mole. Okay, mass in how many mole? In 1 mole is equal to molar mass. So has a unit of kilogram mole inverse. What about molar volume? Molar volume is equal to what? Volume per mole, which is measured in what? Meter cube mole inverse. Molar volume is what? Volume per mole. Volume of substance in 1 mole. Avogadro number. This Avogadro number is very important, guys. Pay close attention. What is Avogadro number? Is numerically equal to the number of atoms in 0.012 kilogram carbon 12. Its value is equal to 6.02 times 10 power 23 mole inverse. What is Avogadro number? In Avogadro number, 1 mole is equal to how many atoms? 1 mole or 0.012 carbon 12 is equal to how many atoms? Is equal to 6.02 times 10 power 23 mole inverse. Guys, in 1 mole, how many atoms do we have? 1 mole, it means that 0.012 carbon 12. How many atoms do we have in 1 mole? In 1 mole, we have this huge number of atoms, which is called Avogadro number. What is Avogadro number? Is the number of atom in 1 mole. Is the number of atom in how many moles? In 1 mole. Okay, guys. The forces holding matter together, unlike the case of gases, it is very difficult to compress solid and liquids. Why? Because the solids incompressible to decrease their volumes. The particles of the liquids and the solids are very close together. The particles of liquid and solid very close together, which requires extremely large forces to bring them even closer. Because the particles in the solid and the liquids are close to each other, so it requires more force to change its volume and its shape. So it is very difficult to bring the neighboring atoms very close together, like in a solid and liquid, because of the repulsion between their electronic clouds. So the distance between the atoms are very close to each other, and the force that holds between the atoms in a solid state is the repulsion force. So this repulsion force is very large, so we cannot, like, for example, change and compress, and we cannot overcome this repulsion force that exists between the 2 particles in a solid state. So that is why solid is incompressible. If the 2 atoms, so between any 2 atoms of an element, there exists a force of attraction due to their bonding, even they were uncharged. And if the 2 atoms are far away from each other, then this force of attraction becomes a very weak. In a large distance, the attraction force becomes weak. Okay, in a large distance, this attraction force will be weak, but the attraction force between the particles is various. It depends on the position. Okay, sometimes this attraction force is very strong, and sometimes this attraction force is very weak. When does the attraction force between 2 atoms in the solid state becomes very weak? In a large distance. In a large distance, the attraction force between the molecules and the atoms is very, very weak. If 2 atoms are close, then they attract each other. When the distance between the 2 atoms becomes extremely small, or they are practically touching each other, their electron clouds repel each other. In a small distance, the force between the particles becomes repulsion force. Then in a large distance, more than equilibrium distance, this force becomes attraction force. Close atoms attract each other and move together as much as their electron clouds allows this. The 2 atoms are in a state of equilibrium. When does 2 atoms are in a state of equilibrium? When the summation of the forces on each of them becomes 0. At a state of the equilibrium, the force between them becomes 0. If the atoms try to separate, the force of attraction does not allow this. If they try to become even close, the repulsive force of the electron prevents them to do so. Okay? Now, I will explain the attraction force, repulsion force, and the 0 force equilibrium state between the atoms of the molecules. According to this figure, guys, figure 2.3 in the book shows the dependence of the force between the atoms of two molecules of the distance between them. Guys, look at this figure. In this figure, we have force, okay? So here force is equal to 0, and we have positive force and negative force. Positive force, negative force. Above 0, we have positive force. Below zeros, we have a negative force. The positive force is repulsion force. Here is what? Repulsion force. Repulsion force. But here we have what? We have attraction force. What we have here? We have attraction force. Attraction force. Look at the curve. So the curve will be like this. And this is distance, guys. What is this? Distance, okay? This straight line is what? This is distance. Sorry. This is distance, okay? The equilibrium distance located at the point when this green line is intersected with the distance. So this green line intersected at this point. So at this point, when the green line intersected with the distance, is called equilibrium distance. What do you mean by R naught? R naught is equilibrium distance. What is R naught? Equilibrium distance. Measured in meter, okay? So the distance away from the R naught, like this point, okay? The distance away from the R naught is bigger than R naught, so the force becomes attraction force. Like for example, at this point, look, each point on the green line that below this curve is what? Attraction force. So when does the force between two atoms becomes attraction force? If the distance between the two atoms bigger than R naught. Okay? So when R bigger than R naught, force becomes what? Attraction force. It becomes what? Attraction force. So how about if R less than R naught, the force becomes what? Repulsion force. Repulsion force. So which point on this green curve is smaller than the equilibrium distance? Now I'm going to tell you this point, guys. These points are the distance is less than equilibrium distance. Okay. So the brown side becomes what? Repulsion force, and like the blue side is what? Attraction force. The blue side is more than equilibrium distance, but the brown side is less than the equilibrium distance, and the force between them becomes repulsion force. So this is repulsion force for a small distance, and this is attraction force for a large distance. As the distance becomes more and more between the particles, the attraction force becomes less, and the attraction force decreases. This point is what? Equilibrium distance. The equilibrium distance. Okay? When does an atomic force becomes an attraction force? Or when does an atomic force become an attraction force? If the distance between any two atoms more than equilibrium distance. More than equilibrium distance, the force becomes what? Attraction force. How about the repulsion force? When does the force between two atoms becomes repulsion force? If the distance between two atoms less than equilibrium distance. Guys, be careful. To determine the force between the atoms, you have to compare with what? With the equilibrium distance. If the distance between two atoms bigger than the equilibrium distance, the force becomes attraction force. But if the distance between two atoms less than equilibrium distance, the force becomes attraction. So how about if the distance between two atoms is equal to the equilibrium distance? In this case, the force becomes 0, and we don't have repulsion and attraction force. And we say that these two atoms are in a state of equilibrium. When does the two atoms are in the state of equilibrium? If the distance between any two atoms equal to equilibrium distance. Okay, guys. When does the two atoms are in a state of equilibrium? If the distance between any two atoms equal to equilibrium distance, R is equal to R naught. In this case, we can say the distance, the two atoms are a state in equilibrium. When does the atoms are a state considered to be an equilibrium state? If the distance between two atoms is equal to the equilibrium distance. Another topic in this section, guys, about the bond. What is bond? A force leading to the attraction among the atoms of an element due to the mutual interactions among its positive and negative charges. So we have three different types of bonds. How many types of bonds do we have? Three different types of bonds. Look. Ionic bond, and covalent bond, and the last one is metallic bond. Now I will explain one by one. What are the main types of bonds? There are three main types of bonds: ionic bond, covalent bond, metallic bonds. What is ionic bond? The strongest bond between the molecules. Form when one atom transfers an electron to another atom. So when does the ionic bond exist or forms between two atoms? If or when one atom transfers an electron to another atom. Okay, so this creates two oppositely charged ions that are attracted to each other by electrostatic forces. Ionic bonds are typically strong and brittle. So the ionic bond is very, very strong and the strongest bond between the atoms. So it forms between metal and non-metal. Ionic bond forms between what? Between metal and non-metal. A common example of the ionic bond, sodium chloride. Like for example, what is the sodium? In ionic bond, electrons are transferring, or transfer electron. Transfer electron from one atom to another. From one atom to another atom, okay? Transferring between two atoms, okay, like one atom loses electron and the other gaining electron. The atoms that loses electron becomes positive ion, and the atoms that gaining electron becomes negative ion, okay? So when does the atom becomes positive ion? When it loses or gains electron, when it loses electron. In the case of losing electron, the atom becomes positive ion. But in the case of gaining electron, when does an atom becomes negatively charged or negative ion? When atoms gaining one or more electrons. Okay? So transferring electron between the atoms is what is ionic bond. Okay? So the bond that exists between two atoms because of transferring electrons is ionic bond, and forms between metal and non-metal. Like for example, in a sodium chloride, as you can see here, for the sodium, how many electrons do we have in the outermost shell? Because we have to look in the outermost shell of sodium. We have only one electron. How many electrons do we have in the outermost shell in the sodium? We have only one electron. So, how about the chloride? Chloride has 7 electrons in the outermost shell. How many electrons does it have? 7. 1, 2, 3, 4, 5, 6, 7. How many electrons do we have for the chloride in the outermost shell? We have 7 electrons in the outermost shell. So this electron is not stable here. So by giving them energy, this electron transfers from the sodium to what? To the chloride. It becomes what? The outermost shell of the chloride becomes what? This electron transferred from sodium to chloride. It becomes 8 electrons. Okay? As you know, in the outermost shell, the filled shell must be 8 electrons in the outermost shell to be stable. Okay? Now, how many electrons do we have? We have 8 electrons in the outermost shell of the chloride. So the transferring electron between two atoms, atom of sodium and chloride, transferring electron is what? Ionic bond. So The sodium, how many electron lost by the sodium? 1 electron. So the sodium becomes positive ion or negative ion? Because the sodium loses electron, it becomes positive ion. Na, guys, look. Na, positive or negative? Positive ion. Why? Because it lost electron. How many electrons? 1 electron, positive one. NaCl. How many electrons gained by the chloride? 1 electron gained by the chloride. It becomes what? Negative charge. So the positive one and the negative one above the Na and Cl indicates that sodium lost 1 electron and chloride gained 1 electron. The atoms that losing electron becomes positive ion and the chloride becomes negative ion. The second type of covalent bonds, when atoms are unable to gain electrons to complete partially filled shells, they can share electrons. Sharing electrons between two atoms is called what? Covalent bond. The bond that formed between two atoms by sharing their electrons is called what? Covalent bond. What is the difference between covalent bond and ionic bond? In ionic bond, the electrons transferring between the atoms. But in covalent bond, instead of transferring electron, the two atoms are sharing together. Sharing what? Sharing electron in the outermost shell. Like the oxygen, okay? Like the oxygen, O2, as you can see here. How many electrons do we have for the oxygen in the outermost shell? We have six electrons. 1, 2, 3, 4, 5, 6. Okay, this is oxygen. Okay, another oxygen. Also, it has 6 electrons. Okay, so 6 electrons. The outermost shell of the atoms must have 8 electrons. Okay, the outermost shell of any atom must have how many electrons? 8 electrons. In this case, how many electrons left by of the oxygen here? 2 electrons. Okay, we need 2 electrons to become 8 electrons. For the second oxygen also we need 2 electrons to become 8 electrons. In this case, the oxygen, by giving more and more energy to the oxygen, these electrons are fixed in the outermost shell. The electron does not transfer between the oxygen atoms. So in this case, instead of transferring, they sharing between them. So what happens after sharing? Look, the sharing electrons, already we have 6 electrons here. Okay, so these 2 electrons are sharing between the outermost shell of the oxygens. Now, for this oxygen, how many electrons do we have? 1, 2, 3, 4, 5, 6, 7, 8. For the second one, 1, 2, 3, 4, 5, 6, 7, 8. So this is the ion, the covalent bond between the oxygen, O2. This is O2. Okay. In the covalent bond, the atoms are sharing to making this bond. Shared electrons act as a bond between the atoms. This referred as a covalent bond. In the case of the oxygen molecules, in this figure, each oxygen atom has 8 electrons, 2 of them in the first shell and the other 6 in the second shell. If each atom shares its neighboring with the 2 of its electrons, the outer shell of each atom will then be full of electrons, and the bond between the 2 shared electrons of the 2 atoms is called the covalent bond. Oxygen has 8 electrons, 2 electrons in the first shell and 6 electrons in the outermost shell. The last type of bonds, in a metal bond, the atoms lose their outermost electrons, which move freely inside the metal. Okay? In the metallic bond, the last type, guys, look. In the covalent bond, the atoms are sharing electrons. Sharing electrons between molecules. But in the last type, metallic bond, the electrons are moving freely. The atom does not transfer from one atom to another atom, and does not sharing electrons, and instead they are moving freely. In which type of bonds the electrons is moving freely between the atoms? In the metallic bonds. The atoms lose their outermost electrons, which move freely inside the middle. As you can see in this figure, this is free negative electron moving among the atoms. Okay? So we have some important equations to determine the density and to determine the molar volume. Okay? Molar mass, sorry, this is wrong. Molar volume is equal to molar mass per density. And guys, we have some equations. Density, to determine density, is equal to what? Molar mass over molar volume. Okay? This equation can be used to determine what? Density. Molar mass over molar volume. If you rearrange this equation, molar volume is equal to what? Change this position. Molar mass over density. Okay? Another equation to determine the distance between two atoms, two neighboring atoms, L. What do you mean by L? The distance between two neighboring atoms, like, is equal to the cubic root of what? Volume for one atom. What do you mean by this V? Volume for one atom. Okay? This equation can be used to determine the distance between two neighboring atoms. Another equation to determine or find the volume for single atom. Volume for one atom or volume for single atom. For how many atoms? One atom. Is equal to what? Molar volume divided Avogadro number. What about mass for one? This should be molar mass. Guys, molar mass. This is not. This is molar mass over Avogadro number. And sorry, mass for one atom is equal to what? Molar mass over Avogadro number. Molar mass over Avogadro number. By using these equations, we can determine distance between two atoms, molar volume, molar mass, and density. Okay? Look at the sample problem. Sample problem 2A. Estimate or calculate. Calculate what? The distance between two atoms. Distance between two atoms. What do you mean by distance between two atoms? It means that L is unknown. What is unknown? L is unknown. Distance between two atoms. Okay? Of copper, knowing that it is molar mass. Knowing that molar mass. What is this 0.064? This is molar mass. Molar mass is equal to what? 0.064 kilogram. What is this? Molar mass. It is density. Density is equal to what? 8,000 kilogram per meter cube. 8,000 kilogram per what? Meter cube. Assume that the Avogadro number is given, but you have to memorize and you have to keep in your mind Avogadro number is equal to 6.02 times 10 power 3 per mole. Avogadro number is given 6.02 times 10 power 23 mole inverse. Okay, what is unknown? The distance between the two atoms. Okay, guys, look at this question. How can you determine the distance between two atoms? It is very important. At first, you have to make your plan. So our plan in this question is to determine the distance between two atoms. Okay, which equation can be used to determine the distance between two atoms? Look, which equation can be used? This one. This equation can be used to determine what? The distance between two atoms. Okay, L is equal to what? Cubic root volume for one atom. Okay, so do we have volume for one atom? Volume for one atom? No, volume for one atom is not given. How can you solve distance between the two atoms without volume for one atom? It's impossible. We cannot. So we have to think about that. We have to determine volume for one atom. Volume for one atom. Which equation can be used to determine volume for one atom? This equation. Molar volume over Avogadro number. Molar volume over what? Over Avogadro number. In this equation, we can determine what? Volume for one atom. After find the volume for one atom, replace into this equation to determine what? The distance. Look, do we have Avogadro number? Yes. Do we have molar volume? No. We don't have molar volume. How can we determine molar volume? To determine molar volume, if you remember, density is equal to molar mass per molar volume. Rearrange this equation. To determine molar volume is equal to what? Molar mass over density. Molar mass, do we have molar mass? Yes. 0.064 divided by 8,000, which is equal to, now I'm going to tell you. Okay, so the distance between, so this is the molar volume is equal to what? Is equal to 0.064 divided by 8,000 is equal to 8 times 10 power negative 6. Negative 6 what? Meter cube per mole. What is this? This is molar volume. Replace this into this equation to determine what? Volume for one atom. Replace the molar volume into this equation to determine what? Volume for one atom. Molar volume we didn't have, but we found 8 times 10 power negative 6 divided by Avogadro number 6 point times 10 power what? 10 power 23 is equal to what? 8 divided by 6.02 is equal to 1.32 times 10 power what? Negative 29 meter cube. What is this? This is volume for one atom. After find volume for one atom, replace into this equation to determine what? The distance between two atoms. So this is the unknown of the question. Cubic root of what? 1.32 times 10 power negative 29 by calculator is equal to 1.2, I think, times 10 power negative 10 meter. Approximately the distance between two neighboring atoms in this of the copper is equal to 1.2 times 10 power negative 10 meter. So this is very important. So in this way, you can determine the length and the distance between two atoms. Okay. Practice 2a, the equilibrium distance between, so you can screen the answer of this question. After that, you have to solve and you have to practice. How can you determine the distance between two atoms? Because the practice in this question is very important. All the students, you have to practice the questions and the practice that we studied and that we solved here, okay? The equilibrium distance between two neighboring atoms of given element is equal to what? 1.2 times 10 power negative 10. What is this 1.2 times 10 power negative 10? Question 1. Practice 2a. Question 1. The equilibrium distance is given, guys, 1.2 times 10 power negative 10 meter. Would the interatomic force be attractive or repulsive for when the one distance between the atoms is A, B? A, 1.2, A, R is given 1.2 times, sorry, 1, not 1, 2, 1 times 10 power negative 10 meter. You have to compare with the R naught. R, 1 times 10 power negative 10, R naught, 1.2 times 10 power negative 10. Which one is bigger? R naught or R? Absolutely R naught bigger than R. When R naught is bigger than R, the force becomes what? Repulsion. The force becomes what? Repulsion force. But the first one answer is what? Repulsion. Why? Because the distance is less than equilibrium distance. For the less distance, force is repulsion. Branch B, R is equal to what? 1.4 times 10 power negative 10 meter. So R naught 1.2, R 1.4. Which one is bigger? R bigger than R naught. R bigger than R naught. If R naught less than R or R bigger than R naught, the force becomes what? Attraction force. Becomes what? Attraction force. Okay? What are the three types of the bonds? Ionic, metallic, and covalent bond. We studied. Are these bonds due to the electric force or the gravitational force? Absolutely, the electric force between the negative charge and positive charge, negative ion and positive ion. The bonding exists between the atoms because of what? Electric force, not gravitational force. Guys, we finished this section. Now we are going to solve the questions of the section review. Does matter change from one phase into another due to the exchange of mass or charge or energy? Energy. By giving them energy, the phase of matter converted from one phase to another phase. By giving what? Energy. Potential energy, kinetic energy, thermal energy, okay? The matter changes from one phase into another phase through the kinetic and potential energy. Question 2, repulsion between atoms at very close distance. At very close distance, interaction between their electron clouds. Is this repulsion due to the fact that electrons are very small to their charge or their mass? Very small or to their charge or mass? Charge. The repulsion force due to their interaction between the same charges of electrons. In the case when two atoms are very, very close to each other, the force becomes repulsion force. Why? Because the electrons in the outermost shell of each atom becomes repulsion. Okay? Electron with electron repel. Like charge repel, opposite charge attract. Comment on the force distance curve between the atoms in the three following regions. If R is equal to R naught, force is what? 0. Force if R, question 3. If R is equal to R naught, force is equal to what? 0, equilibrium state. What about if the distance approaches 0? Distance approach 0, what happens to the distance? Decrease or increase? Decrease. For the decreasing distance, the force becomes repulsion force. R approaches to the infinity, becomes attraction. A, 0 force. B, repulsion. C, attraction. Look at question 4. Question 4 in practice, in section review. The molar mass of sodium. What is this molar mass? 22.98 gram. What is the molar volume? What is unknown? Molar volume. Knowing that the density 9.71, density 9.71 gram per centimeter cube. So we don't need this temperature. This temperature was given just for confusing the students. Be careful, okay? How can you determine the molar volume? To determine molar volume, at first write down the equation of density. Molar mass over molar volume. Rearrange this equation. Molar mass times density. But before substituting into the equation, look at the units. Gram with gram match to each other, they are equal? Yes. So don't convert molar mass and the density. Why? Because the two units are matching each other and they have the same unit, expressing the same unit. But the result of the volume must be centimeter cube. Okay? So in the case when the molar mass was given in kilogram, kilogram is not matches with the gram, you have to convert this kilogram to the gram. Okay? But in this case, these two units are matching each other and not necessary to convert each of them. Okay? Now replace molar mass. 22.98 times 9.71. The molar volume is equal to, like, guys, look, 22.98 times 9.71 is equal to 223.14 centimeter cube. If you want to convert this centimeter cube to meter cube, how? How can you convert centimeter cube to meter cube? Multiply 10 power negative 6. 10 power what? Negative 6 in meter cube. So the final result in meter cube is equal to molar volume. Molar volume is equal to 223.14 times 10 power negative 6 meter cube. Both are correct. Okay? So you can screen the answer of this question After that, you have to write down, okay, on your notebooks. Section 2, the solids and their properties, the composition of the solids. In this section, guys, we are focusing on the solid state only, okay? In section 1, chapter 2, we studied generally about the phase of matter and the force between the molecules, and the zero force, attraction force, repulsion force, and we distinguish it between the phase of matter and the ionic, the bonds between the molecules of the atoms. But in this section, section 2, we are focusing only on the solid state. On what? Solid state and the properties and the composition of the solid state. What are the properties of the solid state? Has a definite shape and definite volume. It is incompressibility, we studied, and has a high density, okay? So the rigid structures, the molecules vibrate around their equilibrium position at its position, okay? The displacement of the particles is zero. The particles does not slide, does not move freely in the solid state. All particles attach it and pack it together. So that is why the solid state has definite shape and definite volume, okay? So the solid is denser than the liquid and the gas. What are the variables that affect how molecules are arranged in the materials? The shape of molecules, the magnitude of the interatomic force of attraction, and the temperature of the materials. The composition of many solids vary with the temperatures. Like the composition of the solids is different from one solid to another solid. Some solids require less amount of energy as a heat to burning, like wood, plastic. But some solid states requires more energy as a heat, like metal, aluminum, and copper. Okay, so it depends on the way its molecules are arranged. Mechanical properties of a solid. Rigid body. What is rigid body? Rigid body, like this mobile phone is a rigid body. Okay, the rigid body, if you like, compress or by applying a force on the mobile does not deforming. Why? Because it is rigid. Okay, like disc, wall, okay, wood. These are examples of a rigid body. Rigidity. What is rigidity? Is like a body that preserve what? It is shape when forces are applied on it. Preserve what? It is shape when forces are applied on it. Okay? A rigid body is one that conserves its shape when forces are applied on it. It doesn't change shape as in the case of the gas and liquid. All rigid bodies are solid. All rigid bodies are solid, but all solids are not rigid. Vice versa is not true. Pay attention, guys. Listen carefully. Once again, all solids are rigid, but all rigids are solid, but all solids are not rigid. Some solids rigid, some solid not rigid. Like a paper, clothes. My clothes is a solid, but it's not rigid. Okay, why? Because it is deforming after a force applying on it. All rigid bodies are solid, but not all solids are rigid. We actually neglected this small displacement under the applies. Okay, this is not important. Distinguish between the rigid and non-rigid in the shape and their force. Maintain its shape. Deformation is zero in the rigid body. Can change shape and size. Particle spacing. The distance between particles remain constant, doesn't change. The distance between particles can change. Example of rigid: glass, baseball bat, textbooks, okay, slinky, Play-Doh, and balloon. The donut also is example, like clothes, okay, non-rigid objects. There are many other objects which suffer noticeable change in the shape under the application of the forces. Your sleeping mattress, for example, deforms. When does the sleeping mattress deform? When you sleep on it, when you exert the force on it. The same thing happens to the tennis ball when it is hit by the bat. Okay? So what is the elasticity and other properties of the solid after we study the rigidity? The rigid body, a body that can preserve its shape when the force applied on it. Now we are explaining the elasticity, the ability of a body to restore its original shape after being deformed under applied force, such as spring, rubber bands, sleeping mattress. What is the elasticity? The ability of a body to restore its original shape. To restore what? its original shape. Like for example, this spring has elasticity, okay? After the force applied on the spring to stretch the spring, what happened to the spring? Restored. Restored to what? To its original shape. So can we say this spring has elasticity? Yes, of course. Why? Because when the force applied on the spring, it goes to stretching the spring, okay? After removing the force, what happened to the spring? The spring returned to its original shape, okay? So this type of the solid object is called the elasticity, the ability of a body to restore. Restore what? Its original shape after being deformed under applied force, such as spring, a rubber band, and the sleeping mattress. When you are sleeping on the sleeping mattress, what happens to the sleeping mattress? It's going to be deforming, but after when you are, for example, when you release this force on the sleeping mattress returns to its original shape. If an object can restore its original shape after being forced, a given force, then the body is called elastic. Okay? So as you can see in this figure, when the force applied on the spring will be compressed, but when the force removed, return to its original shape. The difference between elasticity and non-elasticity. Object behavior after force removal, return. After force removal, what happens to the object when the object has elasticity? Return. But if it doesn't have a elasticity, does not return. Remain deformed. Force required deformation can occur with a small force, requires a large force to overcome the elastic limit. Example, rubber bands, putty, clay, and some plastics. Another topic in this section, tension, is the force which arises in a body while being stretched or compressed. Like is a force which arises in a body while being stretched or compressed. Like for example, if we have a spring, okay, there is no tension on the spring, okay? We don't have tension, no tension, okay? But if we suspend mass, so can we say this spring is under tension? Yes, of course. This is under tension, guys. This spring is what? So the tension, it goes to stretching and compressing the spring or the elastic object. But without tension, the spring and the elastic object does not stretch and does not compress. One of the properties of the solid is ability to stretch or compress. A wire stretches when it is exposed to force, so that it is when we say that the wire is under tension. Tension measured in what? In Newton. Measured in what? Newton. Stress, the stress applied to the elongate a wire is defined as the force per unit area. What is stress? Force per unit area. Force, tension, per unit what? Per unit area. What is this stress? Tension over what? Over area. Okay? So according to this triangle, tension, stress, area. Stress equal to what? Tension over area. Tension equal to what? Tension. Stress times area. Area is equal to what? Tension over stress. Okay, we can rearrange this equation. This is the main equation. Stress measured in what? According to this equation, tension measured in Newton, area meter square, Newton per meter square is the unit for what? Stress. It is equivalent unit is what? Pascal. What is the equivalent unit of Newton per meter square? Pascal. Equivalent unit of stress is Pascal. Okay? Stress, tension over area. What is stress? The force applied on a unit area. Tension over area. Tension over what? Area. SI unit of stress, Newton per meter square, which is equal to Pascal. Okay? What is the equivalent unit of Newton per meter square? Pascal. So we have two types of the stress. What are the types of stress? Two types. There are two different types of stress. Tensile or compressive stress and shear stress. The tensile and compressive stress, like for example, if we have a wire, this is assume that this is wire. When the force applied on this wire, this is force perpendicular. perpendicular to the area of the wire, okay, this type of the stress becomes what? Tensile stress. What is this? This is tensile stress. Tensile stress. Or when the force applied perpendicular to compress the wire is also becomes what? Tensile stress or compressive stress. Compressive stress. So when does the types of the stress becomes tensile or compressive stress? When the force applied perpendicular. Okay? So tensile stress or tensile compressive stress when the applied force is what? Perpendicular, guys, to the cross-section area of the wire. How about the shear stress? When does the stress become shear stress? When the force applied tangent to the direction of the cross-section area. Okay? Like for example, if the object is like this, okay, and the force exerting tangent to the area, the angle between tension and area is parallel. In shear stress, the type of the stress becomes what? Shear stress. Okay? So when does the stress become shear stress? When the force applied tangent direction of the cross-section area. When does the stress become tensile or compressive? When the force is perpendicular to the cross-section area of the wire. When does the stress will be tensile? Perpendicular, parallel or tangent. Okay? Guys, another topic in this section is strain. What is strain? Is equal to elongation over initial length. An elastic spring elongates under tension. Without tension, the spring does not elongate. What do you mean by elongation? The amount of the stretching or compressing of the spring. When the tension is removed, the spring returns to its original shape because of the elasticity. If the tension is very large, and exceeds the limit of the elasticity of the spring, then the spring undergoes a permanent deformation and in its loops, and it doesn't return to its original shape. When does the spring does not return to its original shape? When the applied force is very large and exceeds the limit of the spring, because each spring has its own limit. When the force is more than this limit, the spring does not return to its original shape. When does the spring does not return? If the tension is very large and exceed the limit of the spring. What is Hooke's law? Proved that in 17th century that the tension in a spring is directly proportional to the elongation. This is the equation of strain, unitless. It is unitless, guys. Why? Strain has no unit because elongation measured in meter, initial length meter, meter with meter cancel. Okay? Hooke's law. What is Hooke's law? Hooke's law stated that tension is directly proportional to what? To the elongation. Okay? So elongation is equal to what? Tension over K. K is equal to what? Is equal to tension over elongation. What is relation between elongation and K? Inverse. What is relation between tension and elongation? Is directly proportional. As the tension increases, what happened to the elongation? Also increases. Okay? So this is stated by the Hooke's law. Tension is equal to K times elongation. At constant K, more tension has more elongation. That's all for today, guys. Inshallah, in the next lesson, we are continuing explaining section 2, and inshallah, we will finish chapter 2, and inshallah, we'll start chapter 3 that included for the semi-final exam. I hope you get benefit and get advantage from my lessons. Keep up your best doing, and you have to practice all the questions that I solved with here. So if you have any question, feel free to upload your questions in the comments. Inshallah, I will answer. Thanks for listening.